Hey everybody, thanks for joining my session. I'm Bryan Krausen, and today we're going to talk about how to migrate your Vault cluster to using integrated storage. So a quick introduction about myself here. So again, Bryan Krausen, I'm a principal solutions architect. I'm on all the social media and GitHub and all that at BT Krausen. I'm a consultant and I specialize in HashiCorp and AWS solutions, specifically around Vault and Consul. I'm an exam contributor for the associate exams along with the professional exam that was just recently announced. Co-author of the Running HashiCorp in Production book. I'm also an independent content creator. So I've trained over 15,000 students on HashiCorp technologies. And I've also presented at HashiConf 2019 and 2020. So again, I'm super excited to be back presenting at HashiConf. So what are we going to talk about today? Well, as I mentioned, we're going to talk about integrated storage and how we can migrate your Vault cluster over to using integrated storage. So I usually want to start off the question with, like, are you running Consul as a storage backend today? Well, if you are, this session might be ideal for you. While there's nothing necessarily wrong with running with Consul, and actually for the longest time, it was the only way to really run Vault Enterprise as a storage backend. It can really increase the complexity of your Vault environment when you're using Consul as your storage backend. Now, again, don't get me wrong, there's nothing wrong with running Consul as your storage backend, but there are definitely simpler ways to run Vault these days using the integrated storage feature. Now, if you are using a different storage backend, this is definitely something where you'll benefit as well. Right, you can migrate from your existing storage backend, regardless of which one that you're using, and you can migrate over to integrated storage. So we'll talk about all that as well. All right, so if we want to take a quick step back and talk about really what are the available Vault storage backends that you can use in your Vault cluster today. Well, you can see on the screen that there's a lot of different options. However, not all storage backends are created equal. Now, some of the storage backends will support high availability, and some of the storage backends are actually supported by HashiCorp technical support. All right, so usually in an enterprise deployment, we want both of those, right? We want to be able to run high availability, right? We want to deploy a cluster, so we have high availability for the Vault service. As well, especially if we're running enterprise, we want HashiCorp technical support, right? So if something goes wrong, we want to be able to pick up the phone and have somebody to call and help us troubleshoot and resolve an issue. So we start narrowing these down, right, in terms of what storage backends we should be using in the enterprise. If we just get rid of the storage backends that do not support high availability, you can see we quickly narrow it down to, there's 8 storage backends on here, right? Now, if we want HashiCorp technical support, we're going to be running Vault Enterprise in our environments. We're going to go ahead and get rid of those. And it basically leaves us down to integrated storage and Consul. Now, Consul, again, was the main storage backend that everyone was using because for a long time before Vault 1.4, it was really the only supported storage backend that you could use for running Vault Enterprise. But again, with Vault 1.4, HashiCorp introduced the integrated storage feature. And again, this is a backend that supports high availability, and it also is supported by HashiCorp technical supports. All right, so if we kind of step back and look at the different architectures between these two storage backends that we want to kind of focus on during this session. If you just look at the Consul architecture, when you're using Consul as a storage backend for Vault, immediately you kind of look at it like, oh, that's not very pretty, right? That looks complex just looking at the diagram here. All right, so we've got a lot of different ports and protocols that are involved with using Consul as our storage backend. You can see we've got our traditional ports that Vault uses, our 8200 and our 8201. But then we also have to introduce all these other ports that Consul requires, right? So we have things like 8500 for the API. We've got 8300, 8301 for gossip and RPC. And those all require both TCP and UDP ports to be open for all this to work, right? So immediately you can look at it and it's like, okay, that's pretty complex, but it definitely works great, right? Now, kind of hard for a lot of new users that they want to deploy Vault Enterprise to actually understand this architecture and go out and deploy it. quickly. It usually takes a little bit of learning and a little bit of education in order to kind of get this right. All right, so let's look at the benefits or the some of the features of using Consul architecture, right? We definitely have some increased complexity, right? So now when we deploy Vault in our environments, we now have to provision both Vault and Consul. On top of that, all of our admins, our architects or our engineers, right? They need expertise on both solutions in order to successfully provision this environment, as well as manage it from a day two operation standpoint, right? It's operationally more complex. Now, from a cost standpoint, if you're deploying, especially on like a public cloud infrastructure, it costs more money, right? More nodes cost more money in a public cloud. And on top of that, even if you're deploying on premises, right, it still requires more resources on those physical servers that you're running in your data center. All right, so again, as we're deploying Vault, we also had to deploy Consul on top of that, and that's just more dollars in terms of operational money that we need to pay out. All right, now when we run into trouble when we're using Consul as a backend, troubleshooting may be hard, right? If Vault happens to go down for some reason, you have to determine whether the culprit is actually Vault itself, or was it a problem with the Consul backend that you're using, right? So now you have two different applications to go troubleshoot just to make sure that you can get Vault back up and running. All right, so troubleshooting is quite a bit harder when you're running Consul as a storage backend. Now, if we switch over to integrated storage, here's the architecture for a traditional integrated storage deployment running Vault, right? And immediately you can see like, wow, this is a lot simpler than the previous diagram we saw with Consul. And when you deploy integrated storage, we're going to have replication between all of our nodes, and it's only going to require our traditional Vault ports. We need 8200 and we need 8201 for replication, right? Looks pretty easy. All right, so let's talk about some of the benefits of using integrated storage, right? Reduce complexity, right, as compared to Consul. Now, all the configuration for integrated storage is all done within Vault itself. In fact, it's almost all done within the configuration file of Vault, and that's something you're already doing when you're deploying Vault. All right, so there's no external systems that you need to deploy when you're using integrated storage. Decrease costs. There's a little asterisk. I should have put a little asterisk on here, a little caveat here. Right now, there are fewer resources that are required for an enterprise-ready solution using integrated storage. Now, Consul is very memory bound, right? It requires a lot of memory because that's where Consul actually stores all of its data. Now, integrated storage is actually disk bound, meaning it's going to store all of its data on disk. So when I say there might be a little asterisk in terms of costs, you may have to deploy your Vault nodes with a little faster, enterprise level volumes here, so you get higher IOPS and higher throughput for Vault. All right, and lastly, it's easier to troubleshoot. There's no external system like Consul to troubleshoot, since integrated storage is built directly into Vault itself. All right, so definitely much easier to manage from a day two operations standpoint. All right, so have I convinced you yet to move over to integrated storage? If not, we're going to dive in a little bit deeper into integrated storage. And I want to give a quick introduction to integrated storage. All right, so integrated storage was introduced with Vault 1.4, and it allows us to provide a highly available, durable storage backend for Vault. And it does this without relying on any external systems. Now, the way that it does this is it's going to use the Raft protocol, which was actually kind of pulled over from Consul. It's the same exact protocol that Consul is going to use. And it uses that to be able to handle cluster leadership and log management. So as data is written to the active node in a Vault cluster using integrated storage, then the Raft protocol is actually responsible for replicating that data over to all of the other nodes within your cluster. Now, when we talk about writing data, right, all that data is going to be stored locally on each individual Vault node within the cluster, right? So we all get replicated data across all of our nodes, and our individual nodes don't need to have a network hop in order to go over and grab our data from Consul. All right, so let's look at some of the benefits that I just mentioned, right? Similar architecture when we're deploying integrated storage. right? If you are already familiar with Consul and how it works and the protocols and things like that, we have a very similar architecture when we're deploying integrated storage. We have the same quorum requirements that you know and love with Consul, right? If you're running a 5-node cluster, you need a quorum of 3, those kind of things. We have fewer networking requirements. As I mentioned, Raft only uses 2 ports for cluster operations and replication, and we get rid of all those other Consul ports that are required. It's not memory bound, right? Consul is memory bound, but Raft or the integrated storage feature is not memory bound. It is disk bound, but it's not memory bound. All right. And again, there are no network hops that are required because all the data is stored locally. So when you make a request to a Vault node, right, it has all the data locally and it can respond immediately without having to go across the network to find Consul and grab that data. All right, so let's look at all the features that are available in integrated storage today. Now, again, integrated storage went GA in Vault 1.4, and that was in April 2020. And when it went GA, it didn't have all the features. So you can see on the right, I've kind of got, the comparison of features over here. Consul is obviously all the way to the top because that's what we're comparing against, right? And so we have integrated storage over here on the left. When it was first announced, we have support for Vault Enterprise replication. We have manual snapshot capability. So we can take a snapshot of our data and save it locally or move it to, cloud solution or something like that. And then we also have automated join using the configuration file, right? So what I mean by that is inside of your configuration file, you can have retry joins, just like Consul, right? If you're familiar with that. And you can point to all your other nodes. So when you start your Vault service, it would go out and connect to those other nodes and form a cluster for you, right? So as we go on, many features used by enterprises were not necessarily available at launch. All right, awesome that they finally went GA and the new feature is available in Vault 1.4, but a lot of these enterprise features weren't necessarily available at the start. So then if we move on, we look at Vault 1.6 when it was released. 1.6 gave integrated storage definitely some more love, and we got a new operational kind of provisioning features that are generally used in the enterprise. The big thing was the integrated storage auto snapshots. So if you remember before when I said in 1.4, we only had manual snapshots. We didn't have a snapshot agent that Consul had already provided from the enterprise level, right? And so now with 1.6, we get an auto snapshot feature. And of course, this is enterprise only edition. So if you're running open source, you don't have access to this, only for enterprise clients. And you have cloud auto join. So we kind of move up the stack right here, right? We're kind of starting to advance in terms of getting on par with our Consul features. If you don't know what cloud auto join is, by the way, cloud auto join, instead of using a retry join within your configuration file, you can actually specify tags that are attached to your resources on your cloud provider. So if you're running an AWS, you can add tags to either your containers or your instances. Right? And whenever Vault starts up, it actually uses the EC2 API to go scan all those instances in that region for that tag. It grabs the IP address of the ones it finds, and it uses the IP address to automatically join the cluster. So this is super handy, especially if you're automating your deployments of Vault. All right, so we're moving up the stack here, right? We're kind of starting to get on feature par with Consul. Vault 1.7 was finally released. Finally, a huge kind of what I'd say a missing feature, right, was added to Vault integrated storage, but it's still limited in options. And what I mean is autopilot. Autopilot is now available in 1.7, but we didn't get all the features that Consul autopilot has. We got dead server cleanup, we got server health checking, and we got new server stabilization. All right, so again, we're getting closer to being on par with Consul here. And then finally, 1.8, which is one of the latest versions right now. We got some small improvements, right, that continue to be added to integrated storage. We got support for autopilot for HA only, Raft storage, and we got the ability to enable autopilot on DR secondary clusters. So you can see at this point, we're at 1.82 is the current version of Vault, but you can see that there's still a gap right here, right? There's still some missing features for integrated storage as compared to Consul. All right, so we're going to take a look at those missing features in a second. But first, I want to quickly summarize some of those features that are available in integrated storage today. All right, so again, we have replication, We have auto snapshots, so we can set up a schedule for Vault to automatically take a snapshot of our data and then go place that on an S3 bucket or Azure blob storage. We get cloud auto join, so we can use tags and things like that in order to create our cluster versus having to manually update our configuration file pointing to IP addresses and host names and things like that. Nobody likes doing that, right? We want to use something like cloud auto join. And finally, we get autopilot. Autopilot is really helps us in terms of like a day two operations standpoint, right? But we finally get autopilot with integrated storage. All right, so lots of cool features that we have with integrated storage today. But what's missing, right? So let's talk about the few features that I think are still important that need to be added to integrated storage. Now, the first one is automated upgrades. So again, these are features that are already in Consul, but they are missing from integrated storage. Automated upgrades is really cool. This capability basically allows you, to do an automatic upgrade of Vault or Consul, right? In this case, we're talking about Vault, but it would allow you to do an automatic upgrade when you provision additional nodes within your cluster. So, and when I say automatic, it doesn't mean that Vault's going to go and download the newest binaries and install them, and now you're on the newest version, right? Basically, what happens is you're going to provision additional nodes within your cluster, but the new nodes may be a newer version of Vault, right? Maybe you're running 1.7, and then you deploy new nodes at running 1.8. Well, what this allows us to do is as we deploy more and more nodes, as soon as we get to an equal number of the old version and the new version, then what happens is the old version, the nodes running the old version, basically become non-voting members in the cluster, and the new version, the nodes running the new version, actually become voting members. So what that allows you to do is easily remove those old members, right? Maybe automation, maybe you're doing it manually, right? But it allows you to easily remove those old members from the cluster. All right. Now, note that this is probably going to be a Vault Enterprise feature. I can't speak for HashiCorp, but this is a Consul Enterprise feature. So I assume it's going to be a Vault Enterprise feature. Now, the other one that's missing here is redundancy zones. Redundancy zones allow you to deploy your Vault nodes across different fault zones, right? And fault zones may mean something different to you, depending on where your Vault cluster lives. If you're deploying on premises, it may look like something like different racks, right? Maybe different blade chassis in your data center. That could be a different fault zone. In AWS or Azure, it could look like availability zones. All right, so those are different fault zones. And what we can do is we can actually deploy voting members and non-voting members in each different fault zone. And it allows the non-voting members to actually promote itself to a voting member if the voting member happens to become unavailable, right? So on top of that, we actually can scale out our cluster where those non-voting members can actually provide read-only services for our Vault cluster as well. So again, quite a few benefits from a redundancy and resiliency standpoint and a scalability standpoint. All right. Now, again, this is likely going to be a Vault Enterprise feature, just like you see it is in Consul today. All right. So quick comparison summary for these two, right? We have Consul is, definitely our fully featured solution right now, and is again, kind of the baseline for our comparison. Integrated storage right now is almost there. You can see there's a little bit of gap between the feature part, being on feature par there. But, in my opinion, it definitely has enough features to be absolutely production ready, right? Every cluster I'm deploying with customers these days as a consultant, I'm recommending you go to integrated storage immediately and not worry about Consul. Cool. So all this sounds great, right? But how do we actually migrate our existing Vault environment, right? How do we go from Consul to Vault? Well, that's what we're going to talk about. But before we jump into the specifics, I want to quickly mention a few things. Now, since we're fundamentally changing the architecture of our Vault environment, we need to look and kind of take a step back and look at architecture. We need to look at performance, and we need to consider networking, right? So when we talk about architecture, this is typically what a Vault cluster deployed with Consul may look like in your environment, a typical 3x5 deployment. Right, we have 3 Vault nodes, we have 5 Consul nodes at the bottom there. And when you're going to move over to integrated storage, most likely in production, you're going to want 5 nodes. All right, so we're going to need to deploy 2 additional nodes in our Vault cluster. Now, once you do that, we can go ahead and create our Raft cluster, right, between all of our 5 nodes. And once that's up and running, we can get rid of that Consul cluster. And we're basically left with this final architecture, right? Looks a lot easier than what we had with a Consul backend. All right, so we move over to performance. There are a couple of things that we have to consider. CPU and memory, right? Your typical resources when you're deploying nodes in the cloud or on premises or something like that. When we move to integrated storage, we're essentially consolidating all the workloads between both Vault and Consul on a single node, right? Now we're spreading those out across different nodes within the cluster, but again, all those workloads are basically on a single node. So you may need to keep track of your CPU and your memory utilization, trend that out and make sure that you don't need to increase the size of those individual nodes. Now we're talking about storage. Integrated storage, again, is disk bound, so it means it writes everything to disk. So make sure you're using high performance disks and make sure you're providing sufficient volume sizes, right? Last thing you want to do is fill up those volumes and Vault goes down, right? So it's another thing to consider. And finally, networking, similar to Consul, right? The replication within a Raft cluster requires low latency, high throughput connectivity. So you don't want to be spanning a Raft cluster across multiple data centers or cloud regions or anything like that. They all need to be together within a single region or data center. All right, the last part I want to touch on, networking. I mentioned this a little bit earlier, but the networking requirements change when we migrate from a Vault cluster backed by Consul to a Vault cluster now backed by integrated storage. Now, Consul has a bunch of required ports, as we talked about before, 8200, 8201, 8500, 8300, 8301, right? All those for Consul are also require TCP and UDP. But when we move to integrated storage, all we have to worry about is our required ports of 8200 and 8201, right? Super easy. So that means fewer or less attack service, right, for your Vault cluster, on top of fewer firewalls that we have to, or fewer holes that we have to poke in our firewalls internally, right? So we only need those 2 ports across the board there. All right, so now that we understand all the caveats to migrating, what are some of the migration paths that we may have for moving from a different storage backend like Consul over to integrated storage? Well, which strategy should I use depends on what your Vault implementation looks like in your organization. Now, if you have a single cluster will obviously take more time because you're just working with a single cluster, right? But it requires changes to individual nodes within that cluster. What we're going to do is update the configuration file, run migration commands, things like that. I said it was a little bit riskier operation than our replicated environment, and I think you'll see why. But if you do have a replicated environment, most likely that means you're running Vault Enterprise. I think it kind of simplifies the upgrades because you can simply start deploying new clusters within your Vault architecture that are actually backed by integrated storage, and you can slowly get rid of the ones in Consul. We're going to talk about all that as well. All right, so let's jump into single cluster really quickly. So how do we migrate our cluster to integrated storage? Well, first of all, we're going to take a snapshot, right? We should be taking snapshots on a daily, if not hourly or something like that basis on Consul, right? So we want to make sure we have a backup in case something goes wrong. But the good part about this is that as we're working, all the changes are really on the Vault nodes themselves, and we're really not touching Consul. So if something does go wrong during this migration, you can probably just deploy new Vault nodes, point it to the same Consul cluster, and you'll be back up and running, right? So we still want to take a snapshot just in case. Then we have to go through kind of a preparation phase, all right? Updating the Vault configuration file. Remember, our configuration file is where we're going to dictate what our storage backend is, right? Do we point to Consul? Do we point to integrated storage? Do we point to S3 or DynamoDB or something like that, right? That's where we define our storage backend. We're going to execute a migration command, right, to migrate the data from Consul to Raft. And finally, once that's successful, we were able to retire our old Consul cluster. And yes, that is a Consul cluster in the trash can. Apologize for that. But love Consul, just not for Vault anymore. All right. A couple tips to keep in mind here. You want to automate your Vault deployments. Remember, the fundamental architecture of your cluster is changing. Remember to kind of mind your permissions on those Vault nodes. Remember, now we're writing data locally, and the user that Vault is running needs permission on all the paths and the files it's going to write. So that's the biggest thing I've seen so far from migrating from Consul to Raft. Don't forget about your logs, right? New nodes may need agents for to manage log collection. Make sure you enable snapshots when you migrate over to integrated storage. Snapshots are configured differently. They're configured directly with Vault instead of using a separate snapshot agent like Consul does. And finally, I put consider other platform architectures. A lot of customers these days are starting to look at other architectures, things like ARM, right? Because HashiCorp Vault is supported on those other architectures, and those could be considerably cheaper depending on the instances and the cloud platform that you're running on. All right, so our replicated environments. All right, let's jump into that. How do we migrate our replicated environment? We kind of take a step back and look at these enterprise level deployments. A lot of times we're running these across multiple regions, and we have multiple clouds, multiple clusters in each one of those regions, and we've got replication between them. All right, so we got a primary cluster somewhere, right, in one region, and we're replicating to a performance replica, and we're replicating to a DR replica somewhere. So I put together a quick workflow on how we would migrate this. So per cluster workflow, right, we're going to deploy a new cluster. We're going to configure replication to that new cluster. We're going to validate that everything works. We're going to destroy that old cluster once we're good with the new cluster. And then we've got two choices. Whether we're done, we go celebrate like project's done, right? Or we continue with other clusters. We still have other clusters that we want to upgrade. All right, so what does this actually look like? If you hate animated slides, you're really going to hate this one because this is completely animated, but I think picture, speaks 1,000 words here. So we've got 4 clusters, very similar to our last architecture here, right? We've got our primary top left in our primary site, performance replication over to our secondary site, and DR replication to each one. So what is the workflow to do this? So the first thing we're going to do in our secondary site, we're deploy a new cluster running Raft. And then we're going to enable DR replication to this new cluster, right? Assuming everything goes well with that, right? We've really not changed the fundamental architecture yet. We've just added a new cluster. But now what we can do is get rid of that old cluster that's backed by Consul, because now we have a DR replica backed by Raft. Then what we're going to do is we're going to stop this cluster, right? We're going to stop replication. We're going to promote this cluster, the Raft cluster. We're going to get rid of the old one, and we're going to enable performance replication to our new cluster. Then we're going to go and deploy our new DR replica in the secondary site. And now the secondary site is done. All right, now we're going to follow the same process for our primary site. We're going to deploy a Raft cluster, enable DR replication there, get rid of that old cluster, right? We're halfway done already. Now we're going to stop the service on the primary. All right, we're going to promote this cluster to the new primary and reconfigure performance replication over to our secondary. And we're going to go ahead and deploy our new DR cluster in the primary site. And there we go. Primary site is also done. So pretty easy. And I think it's less risky because we're just deploying clusters at a time and then get rid of the old clusters. All right, so we kind of take a step back and look at the review of some of these migration considerations. A lot of things that we've talked about in this session, right? Snapshots, right? Whether that's taking snapshots for backup retention or enabling new snapshots when we move over to Raft. You got to consider things like data migration, networking, configuration, right? Planning clusters, caffeine, right? To make sure that during the migration process. All right. So again, these are all kind of considerations to keep in mind when you're going through this process. All right. So that pretty much wraps up this session. A couple recaps here. To me, integrated storage is definitely ready for prime time, right? And it definitely should be your first choice for picking a storage backend for a new Vault cluster. Remember all the considerations during our planning phases of our migration, right? Make sure your team is involved. And finally, last I want to mention, integrated storage is totally awesome because we can actually get rid of Consul, but Consul still may be right for you, right? Especially if you're running Vault with very high throughput or tons of requests that are going to Vault, maybe, tens of thousands or hundreds of thousands of requests to Vault. Right, Consul may still be the optimal solution for you. So if you're in doubt, definitely consult, your account team or a trusted partner or somebody like that that can help you walk through that. So that's it for me. Definitely appreciate you spending the time and listening to this session. And thanks for joining HashiConf. And look forward to seeing you in another session.